Okay, Assalamualaikum semua. Our topic for today actually is sampling from a unit multivariate normal distribution and maximum likelihood estimation, which is the continuous from the previous lesson that you have learned before this. So in textbook, this topic is in section 4.3, page 168. Okay, so when I said about multivariate normal distribution, which is you have learned before this, you know what is the PDF for multivariate normal distribution, which is we replace the term of mean and also the sigma square with a matrix of variance covariance and also the mean vector, right? Okay, sorry, not mean vector, it is square distance, right? Okay, and then when I said a maximum likelihood estimation, I believe that you are familiar with this term because of you have learned before this in last semester in subject maybe inferential, right? So we know that maximum likelihood estimation ataupun maximum likelihood method, we will use this method to estimate the parameter. Okay, so now our parameter for normal actually is for multivariate is mean vector and also the variance covariance matrix. Alright. Okay, so first of all, actually, you need to know how to ataupun what is the multivariate normal likelihood function. Okay, so to find ataupun to create the multivariate normal likelihood function, we just find the joint density function of x, of random variable x. Okay, so x here adalah vector. Alright, because we deal with the multivariable x1, x2 up to xn is the variable mean vector. Which is x1 mean vector, not mean vector, it is the vector of x. Okay, vector of x, okay, vector of x have the distribution of normal with mean mu. Okay, this is the mean vector. And the variance covariance metric, the notation is big sigma. Okay, P, what is P? P is the how many variable that we have. Okay. Okay, so the joint density function of x1 up to xn will be when you multiply every function of normal distribution. Okay, let's recall the function for normal density function of p-dimensional. Okay, this is the PDF for the normal density function, right? That you have learned before this. Okay, so when we multiply this function several times, you will have this. Okay, which is 1 over 2 pi np divided by 2. Okay, because of we multiply this function several times, so we will have np divided by 2 is here. Okay, and then the absolute value of big sigma power of n over 2. Okay, here actually 1 over 2. Alright, and then okay, the index here will be summation of xj minus mu transpose inverse of the variance covariance matrix, multiply x minus mu divided by 2. This part x mu, this part x mu big sigma adalah matrix ataupun vector. Here adalah matrix. Alright. So this is the way how you find the likelihood function, which is you multiply the function of x. Okay, and then we can replace this part with the other term. Okay, how to find that? Okay, like this. It will be like this. The trace of inverse of the big sigma multiply summation of xj minus x bar multiply xj minus x bar inverse plus n x bar minus mu inverse, all of that divide by 2. Okay, so I think you also familiar with the term of trace. Trace actually adalah matrix. The trace of a matrix is the sum of the diagonal element. Okay, sum of the diagonal element. Okay, so we need to sum of the diagonal element of this matrix. Okay, of this matrix. Okay, so you will get this. Okay, in your textbook on page 168 until 169, there is a detailing about the method how to replace here this term. Okay, how we find the trace here. Okay, but for your level, no need for you to know every detailing of this method. So you just need to know how to find the likelihood function of the multivariate only. Okay, so our intention actually adalah for this topic is to use the maximum likelihood method to find the estimation of mean and also big sigma variance covariance matrix, because of we want to replace the value of the parameter here mu mean vector atau and also the big sigma variance covariance matrix. So we need to know how to estimate this parameter. Okay, so in your textbook on page 170 and page 171, there is a long method how to get the formula of mu hat and the formula of big sigma hat here. Okay, but for your level, for your degree level now, no need for you to know every single thing of how to find this formula. Okay, so maybe in higher level when you are studying inferential, the high level of inferential, so you can know how to find this formula, how to get this formula. Okay, so for now you need to know the formula, you need to memorize the formula of mu hat, how to estimate the mu hat, and also the big sigma hat. So here mu hat is x bar, here x bar is bold, means that x bar here adalah mean vector. You know how to find the mean vector, you have learned before this in the previous chapter. And then variance covariance matrix, we can estimate the variance covariance matrix by n minus 1 divided by n multiply by s. S adalah variance covariance matrix, sample variance covariance matrix. And also you also can find the big sigma hat using this one. But if you have the value of sample variance covariance matrix, so you can use this formula. Okay, small n adalah sample size. Alright. Okay, so next we move to the sampling distribution for x bar and s. Okay, x bar is the mean vector and s adalah sample variance covariance matrix. Okay, so like before this, you know how to find distribution for x. For every x can x1, x2, you need to know how the distribution of x when we are dealing with the multivariate normal distribution. But also here you need to know how to find the sampling distribution for the mean vector and also the sample variance covariance matrix. Okay, so let's recall back how to find the distribution of the sample mean if our variable is single, univariate cases. Okay, univariate cases when p equal to 1. So here will be n1. Okay, here will be n1. So when p is 1, so the distribution of mean x bar will be normal distribution with mean mu, and the variance will be sigma square divided by n. This term you have learned before this from the previous semester. Okay, ni untuk univariate cases. Untuk multivariate cases, it will be x bar, the mean vector, will be the normally distributed with p equal to how many p that you have, how many x that you have. The mean is mu vector, mean vector. Okay, and the variance will be big sigma divided by n. Before this, mu and sigma square divided by n. But now if we deal with the multivariate cases, it will be mu vector and matrix of big sigma divided by n. So you need to memorize this. You need to hafal this theorem. Okay. Okay. Okay, let's see. The next one adalah sampling distribution for sample variance covariance matrix. Okay. Alright, so recall balik for the univariate cases when x square and also x bar is from the normal population. We know that n minus 1 s square divided by sigma square adalah chi square n minus 1. Remember that you have learned before this in inferential subject. Which one? This one. Okay, be familiar with this term. Okay, n minus 1 s square over sigma square adalah chi square with n minus 1 degree of freedom. And we also know that the formula of x square will be summation of xi minus x bar square over n minus 1. You are familiar with this formula. So because of that, okay, when we manipulate this formula, it will be s square multiply n minus 1 equal to summation of xi minus x bar square. So this term will be chi square n minus 1 multiplied by sigma square. Because of that, we can write like this. Okay, univariate cases. And then we also write it as n minus 1 s square multiply s square summation of z square j. Z adalah standard normal distribution. So it will be, okay, so sigma z adalah normal distribution with mean 0 and variance sigma square. Ini adalah univariate cases. So we apply this univariate cases dalam bentuk multivariate cases. Then we can say that Zj, which is matrix of X, J minus matrix of X bar, adalah normally distributed with mean 0 and variance big sigma. Okay, so n minus 1s adalah will be Wishart distribution with degree of freedom n minus 1. Okay, so for this term, Wishart distribution, you have to memorize the new distribution that will be introduced in this chapter. So there is two distribution that you need to memorize now, which is the distribution of mean for multivariate and distribution of S, which is n minus 1s adalah Wishart distribution with n minus 1 degree of freedom. Okay, so this part, this topic you need to more memorize the theorem. Okay, so after this you just make a short note, write down the theorem that you need to memorize. It will help you later. Okay, so this is actually the Wishart distribution. Okay, this is the Wishart distribution. Okay, this is the Wishart distribution. Just for now, you just need to know what is the Wishart distribution. Okay, no need for you to know every single thing of the Wishart distribution here. Tak perlu hafal lagi lah Wishart distribution ni. Just kena tahu of this one. Okay, okay, sampling distribution for S, n minus 1s adalah Wishart distribution with n minus 1 degree of freedom. Okay. Okay, so I harap jelas sampai situ. Ada sikit lagi, which is when we deal with the large sample of X bar dan S. Okay, S adalah samples variance covariance matrix. Okay, this is on topic 4.5 in page 175. Okay. Let's see. Okay, if X adalah large number, okay, large number of independent, okay, causes V1, V2 until Vn, so means that X adalah summation of V. Okay, X adalah V1 plus V2 up to Vn. So we can say that X has a nearly normal distribution and X bar is also nearly normal for large sample size. Okay, because of X adalah large number of independent, so summation of X, when X adalah large number of independent, so we can say that X can be approximate kepada normal distribution because of we are using the theorem of central limit theorem. So X bar pun we also can say that X bar is also normal, approximately normal distribution for large sample size. Right, we will use the theorem of central limit theorem. Okay, itu yang you dah faham sebelum ni. Okay, so sama juga when we deal with the multivariate cases. Okay, so here benda sama macam tadi juga. When Y adalah independent observation from a population may not be normal, but Y bar can be normal distribution when n approximately infinity. Maksudnya n adalah large number, so Y can be approximate kepada normal distribution walaupun y bar can be approximately normal distribution, walaupun y1, y2 may be not a normal distribution. Okay. Okay, in multivariate cases, sama juga, we use the concept of central limit theorem. If x1, x2 up to xn adalah independent observation from a population, may not be a multivariate normal with mean expected of x or mean vector, x bar converge in probability y to mu, and s converge in probability of y to big sigma. So dia kata kat sini, according to the central limit theorem, when x adalah when x having the mean mu vector and the variance covariance matrix big sigma, so square root of n multiply x bar minus mu will be approximately normal with mean mu and variance is big sigma, which is the variance covariance matrix for large sample size. Okay, for large sample size. Okay, so this part you need to memorize at dalam your short note. Okay, another one that you need to, another theorem that you need to memorize is x bar will be nearly normally distributed with a mean mu vector, mu which is the mean vector, and the variance is the big sigma divided by n, which is the variance covariance matrix divided by n for large sample size n. Okay, so this term yang kedua you need to memorize, n multiply x bar matrix x bar minus mu ataupun mean vector of x bar minus mean vector mu transpose multiply big sigma inverse multiply x bar minus mu vector will be approximately chi-square p. Okay, and because of when n is large, the sample variance covariance will be close to population variance covariance. So this term, bila kita gantikan big sigma here dengan s here, sama juga, it will be approximately will be distributed as chi-square p. Okay, dia punya degree of freedom p. Okay, so at this part you need to memorize all the theorem. How many? 1, 2, 3, 4, 5, 6. Okay, 6 theorem that you need to memorize, put in your short note. Okay, itu je yang I nak cover for today. Tak boleh banyak-banyak. Next time, next class kita akan cover untuk QQ plot pula. Okay, so that's all for today. I will give task for you after this. Alright, thank you.